This tutorial focuses on an important quality step prior to the classification and differential expression of the analysis. The delta-CT normalization standardizes the differences in nucleic starting material in our samples, something that is essential for comparing our biological groups. To do that, we normalize our data using a set of endogenous controls that maintain their expression levels despite different experimental conditions. These are the reports we get after a click-and-go execution, and they allow us to check how healthy our controls are and whether the normalization might modify our data. Let's start from the beginning with the Analysis Profile tool, where all normalization settings can be configured before running automatic analysis to get the results. We recommend watching Analysis Profile tutorial to get familiar with this configuration tool. StatMiner provides several methods to establish the set of reference detectors that we can use for the normalization process. We can select all our endogenous controls or allow StatMiner to automatically determine the best subset of endogenous controls to compute normalization. In this case, we can choose between any of the 3 control selection methods available for this purpose. As a whole view, this algorithm evaluates the variability of the expression profiles within each biological group as well as variability between groups. The point is not only to test the stability of endogenous controls independently, but also to take into account the fact that groups of multiple endogenous controls are considered to be more accurate than normalizing data with just one endogenous control. We recommend that you check the user manual to get further into details of these scoring methods. It is important to highlight that there is a very interesting alternative to using our own sets of endogenous controls, the global expression level normalization. The global expression level is recommended when our experiment doesn't include any detector that could take the role of endogenous control. This normalization works best when we are working on a large-scale analysis, regardless of controls or not. Global normalization creates a virtual control by taking into account all the detectors in our analysis, including targets as well as endogenous if they are present in the dataset. As a note, not all detectors are included in this process. Any detector with a missing value or low expression levels will be discarded as a potential in the generation of the virtual endogenous control. However, it doesn't mean that they won't be normalized and included in the next step of the analysis. As we can see, with the exception of the global expression level, the other selection methods allow us to define our set of endogenous controls. What happens if no endogenous control has been defined? Task assignment means the roles of the detector in the analysis, endogenous control or target, should be provided within the input data files. If not, StatMiner will consider all detectors as targets. What to do when we want to define our controls? The application provides a tool from which we can define the detector's role. Are they endogenous controls or targets? Let's open it. As we can see, all our detectors appear properly classified according to the information provided into the input data files. In this case, we are aware of a certain target that would be good as an endogenous control candidate. Search tool allows us to find it easily, and we only need to switch it to endogenous. In short, we have selected the set of detectors to be used to normalize our experiment, in this case all reference detectors. Additionally, we can rely on an automatic algorithm to select best stable reference detectors or just use all detectors that fulfill the global expression level restrictions. What is being done with the final list of candidates to normalize our data? We can see that in more detail later, but as a whole overview, StatMiner creates a new virtual endogenous control as a result of summarizing candidates with this selected method. CT values of this new control will be used as the normalization factor of each sample. With this option, we are advising the application to normalize the endogenous control so they will be available in the final analysis steps. We finished the configuration of our delta-CT normalization with a quality control. When checked, StatMiner automatically processes the stability of multiple random combinations of target to determine whether this random selection is better than our own set of endogenous controls. If so, it is better recommended to use the global normalization and not any endogenous control combination. The ruling of this quality test will be available after running click-and-go analysis on the endogenous control page report. We are ready to execute our analysis and inspect reports related to the delta-CT computation. As mentioned at the beginning of this tutorial, this page works as a summary of the final status of our endogenous controls, what they look like, which one of them was finally used to normalize our data, and in case of an automatic selection method, how the application got to the conclusion of selecting them. Getting into details, this chart shows the CT profile of all our endogenous controls along biological replicates, having a color legend depending on the role they took in the normalization process. The best endogenous controls are in blue. The expression level of an endogenous control is not supposed to be affected by the samples that we are analyzing, neither by their experimental conditions. Therefore, we are expecting to see that our scoring method has selected endogenous profiles with a very low variability, as we can see in this case. On the other hand, in grey are the endogenous controls discarded by the scoring method. If we have decided to use all our reference controls, no controls will be discarded. In this case, we have discarded these endogenous controls either because of their low stability or the existence of missing values or very low expression levels. It is not usual, but in case an automatic scoring method selects such an endogenous control, we will be notified from the information panel with a warning. Finally, this is the brand new virtual control calculated as an aggregation of selected reference controls. Detectors will be normalized, subtracting this profile sample by sample. StatMiner provides full information to help us to interpret scoring method choices, variation, stability scores, etc. As we can see, StatMiner has analyzed those reports, automatically selecting the best endogenous controls for us. Let's finish this tutorial by having a look at the Delta CT computation report. This report helps us to inspect and understand what happens to our data once it has been normalized. On the left, we have a visualization representing the distribution of CT values for each sample before normalizing our data. We can better inspect it by zooming into just one biological group. This is, for instance, the median of the CT values of this sample, and within this range falls 50% of the values for this sample. As we mentioned before, Delta CT normalization is subtracting our virtual control sample by sample, so this is how our samples have been shifted after normalizing data. Differences in the starting nucleic material are now standardized. These are the new detector profiles after the normalization process. We can check normalized expression of any of them by just filtering the desired detector and checking its profile. We will finish this tutorial by saying that the information panel is recording all the settings we have used in the analysis, selected scoring method, endogenous control selection, etc., and any warning message thrown by the quality algorithms. There is nothing to worry about in this case since this endogenous control was not selected. So we are done. Our data has been normalized and we are ready to continue with last steps of the analysis, clustering and differential expression analysis.